Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we're going to solve the 8th challenge in Eternaut together, the Vault challenge with Foundry. So you're gonna learn smart contract hacking while learning the most common framework for smart contract development and auditing, which is Foundry. 2 birds, 1 shot. Now make sure to watch the first video in this series where we explain how to set up the Foundry repository, how the solutions are going to work Foundry together with the Eternaut smart contracts on the Goerli blockchain. So really watch this video because it's a prerequisite to understand how we're solving the challenges here. If you are new here, my name is Johnny Time, and in this challenge I'm gonna post so much alpha content and smart contract security tutorials, so make sure to subscribe and turn on the notification button. Now without further ado, let's get started. So this is the 8th challenge, Vault, and in this challenge we need to unlock the Vault to pass this level. And here we have the Vault smart contract. Before actually observing the contract and trying to find vulnerabilities, I want to click here and create new instance. So it will just send using my MetaMask wallet to get a new instance of this challenge. I will also copy the smart contract code to my local environment. So I will create a new file in the src folder. I will call it vault.sol. This is my Foundry repository. I'm going to paste here the original smart contract, and now we can look at it and see if we can find any vulnerabilities. So the Vault smart contract is quite updated, Solidity version 0.8, and we have 2 state variables. One is a Boolean public locked and bytes 32 private password. In the constructor, we pass the password and we set the state variable locked to true, and we set the password. And here we have the public unlock function, which anyone can call. There is no access control, no modifiers. We pass 32 bytes of password, and if it's the password that was passed through the construction, then locked will be changed from true to false. So all we have to do is just to figure out what password is stored for the Vault, or what password was passed in the constructor as parameter. Now this is a classic CTF challenge, an exercise of sensitive data that is stored on the blockchain. And this is something that we talk a lot about and emphasize in the sensitive on-chain data chapter in the smart contract hacking course. By the way, this chapter comes with 3 amazing exercises like all the other 30 chapters, and in total we have more than 50 hands-on exercises that will take your skills to the next level, including guest lectures from the best professionals from the industry, Trust, Pashov, and Owen. Upon completion of the final exam, you also get a certificate that will help you to land your first job in smart contract security. Also, you get access to the best Web3 security community. You can ask questions, engage with other students and professionals, maybe team up for auditing contests, and do much more. If you like to get access to this amazing course, you can use the discount link in the description below. Going back to our challenge, this is a no. You cannot store passwords on the blockchain. You cannot store secrets, API keys, nothing, because the blockchain is transparent, and even if this state variable is private, we can still access it with tools and different ways. We will see in a moment how. So actually we have 2 ways of solving this challenge. One way is to go to the Blockchain Explorer and try to see what we can find from their website like Etherscan or Goerli Etherscan, because this is on Goerli blockchain. And the second way to solve this challenge is to query the storage slots of this smart contract using different tools. For example, Cast, which is built in Foundry. Now again, if you want to deepen your understanding of the EVM, how smart contract storage works, how accounts and the state works, you should definitely check out the smart contract hacking course. We also have complete tutorial about how to use Cast in depth and challenges with Cast, and we will use Cast to query this storage slot. It's going to be probably slot number 1 because this will be slot 0, so the password will be in slot 1, but we'll see it in a moment. So first thing first, let's try to find the password through Blockchain Explorer. So here we have actually the instance address. This is the contract, the Vault that was deployed for us. Now in this new tab, I open Goerli Etherscan, and I'm going to paste here the smart contract address, and here we can take a look at the contract, and obviously this contract is not verified, so we can see nothing here from the contract code because it's basically bytecode. So we don't get so much information for this contract view because we don't have transactions. The contract is bytecode. We cannot do much with it. But what we can do is go to the transaction of the creation of this smart contract, because we know that the password was passed on the constructor. So if we go to the transaction where the contract was created, maybe we can find some clues about the password. So this is the transaction where the contract was created, and we see here a lot of information like the hash, the status, the block, the from and to, and it doesn't help us so much. Maybe we'll click here more details and see what happens over here. It doesn't help us as well because this transaction was sent to the Ethernet Functree contract to deploy this new smart contract using the create level instance. So the parameters weren't passed through this function, but through some kind of internal function, because this create new level deployed a new contract probably using the create or create2 opcode, and the parameters were passed through the create or create2 opcode. So we cannot see them actually here in the Blockchain Explorer. But there is this very interesting tab here in Etherscan, which is state. This tab shows us all the addresses that their state was changed because of this transaction. Now this is supposed to help us because maybe we'll see the change in the state of this newly vault created smart contract. Maybe we'll see the change from the locked variable from false to true, and the password from 0 to 32 bytes that were passed in the constructor. Maybe we'll see it here. Now we want to see the state changes of this contract CF7. So I will go back and we are interested in this one, CF7, because we can see that a lot of addresses states were changed. For example, this is the nonce was changed here. Also here the nonce was changed and the balance was changed a bit, but we're interested in this particular one, which is this vault smart contract. And if we scroll down a little bit, we can see that two storage variables were changed. Storage variable number 0 changed from 0 to 1, which means from false to true. And storage variable number 1, the first storage slot, this is storage slot 0, this is storage slot 1, changed from 0, from nothing, from 0 bytes to this kind of bytes. And this is probably our password, right? Because this is the first storage slot that was changed from this empty variable to this variable. Because this is the storage slot that was changed from empty data to this data. So this is obviously one way to find the password, but we have also another way. Instead of going to Blockchain Explorers, we can use CLI, command line interface tools such as Cast, which comes built in with Foundry, and we can query storage slots. So OS cast --help will help you to go through all the functionalities. This is an amazing tool. I'm not going to go through all the functions. We do it in the smart contract hacking course, but in this tutorial we'll use only the storage command, cast storage. So we'll do cast storage, and then we need to paste the address of the smart contract that we want to query its storage. So it's going to be this instance address. I'm going to paste it over here, and then we need to pass the second param is the storage slot that we want to query. So let's start with slot number 0, and we see that in slot number 0 we have the 1 data. It's exactly what we saw here in the Blockchain Explorer, this one. Now in storage slot number 1, let's see what we have. We get the password, guys, the exact same password that we saw here in the Blockchain Explorer. Now this is bytes 32, so it's probably in hexadecimal. We want to convert it to string to see the actual password. So I'm going to search in Google hex to string and click here on the first result, and now I'm going to copy this hex value, paste it over here, and see what we get. A very strong secret password. So this is our password, and now we found the password, and hopefully we can unlock the vault. Okay, so to solve the challenge, I'm going to go to the script folder, copy a previous challenge file as a template, rename the smart contract name from not trash. I just want to rename it. So rename, and let's call it a vault solution. There we go. This is our vault solution. We will import vault instead of delegation. We will also change the contract name to vault solution. This will be vault, and here we will do vault instance. And here we have to paste the smart contract address, the instance address. So I will go back to the Ethernet website, copy the instance address and paste it here. Beautiful. We can remove all these kind of commands. And these are commands that will allow us to broadcast the transaction to the Goerli blockchain. Again, if you don't know or not sure about it, check out the first tutorial in this playlist in this series. Now, here we need to basically call the unlock function, because if we go here to the Vault contract, we see we can call this function together with the password. We actually can send the bytes directly. We don't need to send the encoded password, the string. So we're just going to send the byte that we copy from the blockchain explorer or from Cast. So what I'm going to do is simply vault instance.unlock. And here we just need to send the password, and the password we already have it here, or we can copy it from Cast in the exact same password, and that's supposed to be it. This is supposed to be our script solution, and now we can just run it, broadcast the transaction to Goerli, and see if it actually works. So I'm gonna do here forge script, and this will be script and vault solution -- broadcast. And it will broadcast this directly to the Goerli blockchain using our MetaMask account. Again, if you don't know, check out the first tutorial. We did all the setup of the Goerli blockchain, the MetaMask wallet. Awesome, the transaction was sent. We will wait now for the receipt for the confirmation of the validators of the blockchain. And now that the transaction was validated, we can go to the challenge, click here, submit instance, send a transaction with our MetaMask wallet, and let's see if we're able to unlock the vault. We will wait a little bit that the transaction will be verified in the console over here. And we did it, guys. You can see here the well done message, and we completed the 8th challenge in Ethernet, the Vault challenge. Now, if you enjoyed this video, make sure to subscribe to the channel, turn on the bell notification button, and of course smash that like button so the algorithm will show this video to more people that want to learn smart contract hacking through Foundry. Thank you so much, and I will see you in the next one.